All right, so we have talked about simplifying radical expressions, adding and subtracting radical expressions, multiplying them, and dividing them. So today we're going to talk about how to rationalize so that we do not have any square roots, cubic roots, or fourth roots, any kind of radicals on the bottom. So we want no radicals in our denominator. So the way that we do that is by rationalizing the denominator. So if we have something that's a monomial denominator, I did not mean to do that, I meant to highlight it. So a monomial denominator means that it's just one term on the bottom. So this would be like the square root of 5, the square root of 15, the square root of 2, things like that. What we want to do is multiply the numerator and the denominator by whatever the radical in the denominator is. So that'll make more sense when we do a practice problem. If we have a binomial denominator, so that would mean something with two terms. So something that's separated by a plus or a minus sign, we're going to multiply the numerator and the denominator by the conjugate. So the conjugate is the same expression, but with the opposite sign. So if it's a plus, then we turn it into a minus. If it's a minus, we turn it into a plus. And again, that will make a little bit more sense once we actually do some practice problems. So I'm going to go ahead and get started. I think I'm going to do 4 of the monomial denominators and 4 of the binomial denominators, and then I'll have you guys do 2 of each for your assignment today. So starting off, I'm going to start with number 9. So with number 9, as you can see, this is a monomial denominator. There's only one term on the bottom. So what we do to get rid of that, I want no radicals on the bottom. I'm going to multiply both the top and the bottom by whatever my denominator is. So I'm going to multiply both the top and the bottom by whatever my denominator is. So when I do this, I'm going to end up with 3 times 2, which is 6, radical 5, and 2 times 2, which is 4, radical 5 times 5, 25. So all we did there was just multiply just like we would. So I multiplied my coefficients, my outside numbers, and then I multiplied my inside numbers. So if we keep on simplifying this guy, we can simplify the square root of 25 into 4 times 5, which is 20. So now we would have 6 the square root of 5 over 20. And then we need to simplify one more time by saying what number goes into both 6 and 20. So that number is 2. So I could take a 2 out of everything. And then I would have 3 square root of 5 over 10. So all I did for this problem was multiply the top and the bottom by whatever my denominator was, and then simplify. So if I wanted to do a problem like number 10, I need to start by splitting this up to where it's the square root of 8 over the square root of 15. And then from here, this is when I can go ahead and multiply the top and the bottom both by the square root of 15. So when I multiply 8 by 15, I get 120 on the top. So the square root of 120 is on the top, and the square root of 225 is on the bottom. And then I can begin my simplification process. So the square root of 120, that's not a perfect square, but there are perfect squares that go into it. And the one that I think of first is 4 and 30. So 4 and 30. 4 is a perfect square. And then 30 cannot be broken down into any more perfect squares, so it's the perfect match. So if we have the square root of 4, the square root of 30, over the square root of 225 is a perfect square, and that's actually 15. And then we can break this down just one more time. So the square root of 4, that's 2. So what I really have here is 2, the square root of 30 over 15. And that's all I can do here. All right, let's talk about number 11. So first step is to multiply the top and the bottom by 4, the square root of 7. And then we're going to get 3 times 4, so we multiply our outsides by our insides. This is 84. And then we're going to multiply the stuff on the bottom. So 4 times 4 is 16, the square root of 49. So 49 can be broken down, and the square root of 49 is 7. And then we need to think about the square root of 84. What is a perfect square that goes into the square root of 84? So nothing's going to happen to that 12 out front. 84 can be broken down into the square root of 4 and the square root of 21. So from here, I can look at this like square root of 4 is 2. So I really have 12 times 2, the square root of 21 on top. And I have 16 times 7 on the bottom. So if I do that math, I have 24, the square root of 21, over 16 times 7. 16 times 7 is 112. From here, I need to break it down one more time and think about what's the biggest number that goes into both of those. So 112 divided by 2, 24 divided by 2, those are still pretty big numbers. It's 56 and 12. So I could probably do it one more time. I get 6 and 28, so that's still not big enough. Let's see what happens if I multiply it by 8. I get 14 and 6. 14 and 6. So if I multiply, 14 and 3, excuse me. 24 divided by 8, that's where I get my 3 from. 112 divided by 8 is where I get 14 from. So this would be my answer for that one. All right, this one has variables involved with it. So we'll do this one. So when I do this guy, I'm going to have to multiply by whatever my denominator is. So I'm going to multiply by the square root of 3a on top and the square root of 3a on bottom. So when I do that, 28 times 3 gives me 84. And then a to the 5th times a is a to the 6th. All over the square root of 9a squared. From here, I need to break down, my 84. So how can we break down 84? We ask ourselves, well, what's a perfect square that goes into 84? The one that I think of first is 4. So I can break down the square root of 84 into the square root of 4 and the square root of 21, and then I still have my variables involved. All over the square root of 9 is 3, and the square root of a squared is just a. And then I can continue simplifying. So this becomes 2. The square root of a to the 6th, how many groups of 2 are in 6? Well, that's 3, so this becomes a cubed. And I'm going to end up with 2a cubed, the square root of 21, all over 3a. And my last step here is going to be to cancel out one of those a's. So I'm going to be left with 2 on top and none on the bottom. And this purple guy will be my final answer. 2a squared, square root of 21, all over 3. I lied and said that I was only going to do 4, but after looking at it one more time, I've decided to keep going. So I'm going to do the rest of these examples on this page, and then I'll give you a different assignment for your assignment for today. So for number 13, again, we start by just doing what we have been doing, where we multiply both the top and the bottom by whatever our denominator is. So when I do this, I have to consider the numerator in parentheses. So I want to think about the numerator as being in parentheses, which means I'm going to need to distribute. So I'm going to have the square root of 16 minus the square root of 4 over the square root of 4. Because all I did was multiply all of those things into their places. So if I simplify, the square root of 16 is 4. Square root of 4 is 2. All over the square root of 4, which is, again, 2. And then I can just do some simple math here. So 4 minus 2. 4 minus 2 is 2 divided by 2. So my answer here is just 1. Last one here before we go into where I have a binomial denominator. I multiply by the square root of 12 on the top and on the bottom again. But remember, I need to consider the top as a set of parentheses that's together. So I need to distribute that square root of 12 into everything. So I'm going to have 3 the square root of 24 minus the square root of 72 all over the square root of 144. So from this step, I'm going to start by breaking down the square root of 24, which can be broken down into 4 and 6. And then I need to break down the square root of 72. 72 can be broken down into the square root of 36 and the square root of 2. And then that's all over the square root of 144, which is just 12. That's a perfect square. So from here, I identify the things that I can simplify. So the first would be this 4 would become a 2, and this 36 is going to become a 6. And then I'm going to do my multiplication here. So I'm going to do my 3 times 2 to get 6 square root of 6 minus 6 square root of 2 all over 12. I could simplify this one more way. I'm going to make this a little bit smaller. So we would have 6 square root of 6 minus 6 square root of 2 all over 12. 6, 6, and 12 all have 6 in common. So I could take a 6 out of everything. And then I'm going to have the square root of 6 minus the square root of 2 all over 2. And then that would become my final answer. And I'm sorry, I don't know why I said minus the whole time. This was the plus. It's been a long day for Miss Gronefeld. All right, let's move on to things that have a binomial denominator. So binomial denominator, we said that we needed to use the conjugate. So the conjugate is, instead of it being a plus in the middle, we make it a minus. If it's a minus in the middle, we make it a plus. So here, I have 4 plus the square root of 2 on the bottom. So when I multiply, I'm going to multiply by 4 minus the square root of 2 on both the top and the bottom. So what's going to happen here is we're going to distribute. We're going to have to double distribute on the bottom. So this is together. So we're going to do 4 times 4, and we're going to get 16. And then we're going to do 4 times negative the square root of 2 and get negative 4 the square root of 2 we're going to multiply again and get positive 4 the square root of 2. And then minus the square root of 4. And that's going to be our bottom. So I should probably move that down. So on the bottom, we're going to have 16 minus 4 the square root of 2 plus 4 the square root of 2 minus the square root of 4. And on top, I'm just going to distribute the 4 to everything inside of here. So I'm going to have 16 minus 4 the square root of 2. Now some interesting things happen next. These two are going to cancel each other out because I have negative and then plus the same thing. So that's kind of like negative 1 plus 1 gives me 0. And then negative square root of 4 is just going to become negative 2. So what I really have here is 16 minus 4 the square root of 2 over 16 minus 2. So my final answer here, I'm just going to simplify one more time. I'm going to get 16 minus 4 the square root of 2 all over 14. And then I ask myself, is that as small as it can go? Do they have anything else in common? Which they do. They all have 2 in common. So I could factor a 2 out of everything. And I'll end up with 8 minus 2 the square root of 2 all over 7. So this seems like a lot, but it's just a little bit more work. You have to do a little bit more multiplication. And the more that you do it, the more you're going to see sort of the pattern that comes along when you do it. So if we do number 16 here, we need to keep that as a group, and we're going to multiply by 6 plus the square root of 5. So we do the opposite of whatever sign is already there. And then when we do this, we're going to carry out that multiplication. So on top, we'll have 12 plus 2 the square root of 5. And on the bottom, we're going to end up with 36 plus 6 the square root of 5 minus 6 the square root of 5 minus the square root of 25. And then we carry out our simplification. Our middle 2 terms are going to cancel, and this is going to become minus 5. So we'll then have 12 plus 2 the square root of 5 on top over 36 minus 5 on the bottom. When we do this, we're just going to do that, carry out that subtraction on the bottom. And we're going to end up with 12 plus 2 the square root of 5 over 31. And that's going to be our final answer for that one. All right, on to number 17. So just do the opposite sign here. And then we carry out the multiplication. So on top, we're going to have the square root of 3 plus 4, the square root of 6 on the top. And on bottom, we're going to have 1 plus 4 the square root of 2 minus 4 the square root of 2 minus 16 the square root of 4. Simplify a few things. And we get the square root of 3 plus 4 the square root of 6 all over 1 minus 32. Last step is to simplify our denominator one more time. So we have to do the 1 minus 32 part. So here we're going to end up with the square root of 3 plus 4 the square root of 6 all over negative 31. If you look at this one, I'm going to end up double distributing on the top and on the bottom, but I need to start with multiplying by my conjugate. So I'm going to multiply by the square root of 5 minus the square root of 3 here, on both the top and the bottom. I'm going to carry out that multiplication, and on the top I'm going to have 5 the square root of 5 minus 5 the square root of 3 minus the square root of 25 plus the square root of 15 all over the square root of 25 minus the square root of 15 plus the square root of 15 minus the square root of 9. And then I begin my simplification. So this is going to become 5. I can't simplify anything else on the top. This becomes 5. These guys are going to cancel out. And this becomes a 3. So on top we have 5 the square root of 5 minus 5 the square root of 3 minus 5 plus the square root of 15. And on the bottom, we have 5 minus 3. If I do that simplification on the bottom, this just becomes a 2. So we're going to end up with 5 square root of 5 minus 5 square root of 3 minus 5 plus the square root of 15 all over 2. And all I did there to the bottom was that 5 minus 3 part. I have 2 more examples, and then I'm going to let you guys kind of go on your own and see what questions you may have for me. So for number 19, again, we need to start by multiplying by the conjugate. So we're going to multiply 2 minus 2 the square root of 7 on both the top and on the bottom. And then we're going to carry out that multiplication. So on top, we're going to have 6 minus 6 the square root of 7. I need to make this a little bit smaller. Plus 2 the square root of 7 minus 2 the square root of 7. I'm sorry, minus 2 the square root of 49. And on the bottom, we're going to have 4 minus 4 the square root of 7 plus 4 the square root of 7 minus 4 the square root of 49. From here, we see what we can simplify. So down here on the top, we can simplify this to a 7. On the bottom, we can also simplify that to a 7, and we can cancel out our middle terms. So what else we can do here is we can combine these two. So I'm going to have negative 6 plus 2, and I'm going to end up with negative 4. So I'll have 6 minus 4 the square root of 7 minus 14. That 14 comes from this negative 2 times 7 on the end there. All over 4 minus 4 times 7. The 4 times 7 comes from this end on the bottom, and that's minus 28. My last step here is to just combine any like terms. So I have that 6 and 14 on the top. So if I do 6 minus 14, I end up with negative 8 minus 4 the square root of 7 on the top and negative 24 on the bottom. If I wanted to simplify just one more time, negative 8, negative 4, and negative 24 all have 4 in common. So I could take a 4 out of everything, and if I do that, I'll end up with negative 2 minus the square root of 7 all over negative 6. So it's just a lot of multiplication and simplification. We multiply, we simplify. Last one, and then you guys will have your own assignment to do. Again, you multiply the numerator and denominator by the conjugate. And then we carry out that multiplication. So on top, we're going to have 8 times 3, which is 24. 8 times 4, which is 32, square root of 6. Negative 6 times, or negative square root of 6 times 3 gives me negative 3, the square root of 6. And lastly, we're going to have negative 4, the square root of 36. All over our bottom, on bottom, we're going to have 9 plus 12, the square root of 6, minus 12, the square root of 6, minus 16, the square root of 36. And then we do our simplification here. So if we simplify, this becomes 6, 6. These guys cancel, and we can add these two together. So we're going to end up with 24 plus 29, the square root of 6, minus 24, all over 9 minus 96. So if we continue to simplify here, 24 minus 24 gives me 0. So I have 29, the square root of 6 on top, and I have negative 87 on the bottom. 29 goes into 87, surprisingly. And what I end up with is the square root of 6 over negative 3. And that's where I'll stop for today. I will post your assignment under today's assignment. And if you have any questions, please reach out to me. There'll be problems just like this where you'll have to rationalize the monomial denominators and with binomial denominators. So watch out for both of those. I will also post a copy of the notes from today. So if you need to look back and see how I did something, you can look back at that. Please pause the video when you need to. I know I kind of went kind of fast, but we had a lot of examples to get through so that you guys could work on